So this triangle problem, you'll be using Heron's formula for it. Let me just run a sample session with it. So if I say I want the first cut to be 4 feet into the board and the next one to be 8 feet in the board, imagine what that's doing, right? So you have a 10-foot board. I make the first cut at 4 feet. So the first side of the triangle is 4. Then I make the next one 8 feet in the board. So the next side of the triangle is 4. And then I make the last resulting side, if I make a cut at 8, and the board's 10 foot long, that last side will be 2. And that's what your program's gonna have to figure out. It's gonna have to figure out that that triangle is a 4-4-2 triangle. And you're gonna have to do the arithmetic there. You can't just simply use a squared plus b squared equals c squared, because remember, Pythagorean theorem's awesome, but it only works for right triangles. We can't assume that this is a right triangle. In fact, this is an isosceles triangle, right? So if I give those inputs, I'll get 3.8729, blah, 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 blah. That'll be the area of that triangle. I'll give you another sample one. What if I said that it was going to be a 3, I make a cut at 3, and I make a cut at 7. Well, now that's going to be a 3-4-3 triangle, and I should get 4.47. Now, there are some things that could get us in trouble in this program. Like, let's say I made a triangle. I made the first cut at 5, and then I made the next cut at 9, right? The area of that triangle is 0. You have to think about why that is. And we can even make it even worse. What if I said that the first cut was at 1 and the second cut was at 2? Brother, we're going to have some issues there. So anyway, there'll be limitations to the program that you're making. But if you use those test cases to kind of make sure that our programs line up, I think you'll do just fine.